A line L is defined by question A finds the equation of L in the vector form. So we need to get the vector form from the given Cartesian form for a given line. How to do that? You can see that these three expressions are equal, and we can say that they are equal to some constant, let it be lambda. And then we consider this is equal to lambda and just solve for x. This is equal to lambda and just solve for y. This is equal to lambda and just solve for z. So it becomes negative x over 2 plus 1 is lambda. So negative x over 2 is lambda minus 1. Negative x is 2 lambda minus 2, so x is 2 minus 2 lambda. For y, it's just negative 4 plus lambda, and for z, it's 0 plus 3 lambda. It's called a parametric equation of a line, and x, y, z is a position vector of any point on the line, and it is equal to 2, negative 4, 0 plus parameter negative 2, 1, 3. And it's the required vector equation of the line. It's position vector of some point on the line, and it's the direction vector. Direction vector is some vector which is parallel to our line. And it's important direction only. It doesn't matter what length of this vector is. So in general, you can take absolutely any multiple of this vector to be a direction vector. The next question: determine the minimum distance from the origin to the line L. And the minimum distance, it's the shortest distance, and it's to be the shortest distance, it's the perpendicular distance. And this vector R, it's a position vector to any point on the line. But when, since we need the shortest distance, if we consider this vector R to be to some point, so that this vector is perpendicular to the line, hence the magnitude of this vector is the shortest or the minimum distance. But when this vector is perpendicular to the line, if we consider a vector B, it's the direction vector of the line, it's this vector. Since R and B are perpendicular, their dot product is equal to 0. And if we consider dot product, we can find parameter lambda for which vector R is perpendicular to the line. Then magnitude of this vector gives us the required shortest distance. So it becomes 2 minus 2 lambda, negative 4 plus lambda, 3 lambda is our R vector, and dot product with negative 2, 1, 3 is 0. Dot product is x by x plus y by y plus z by z, so it becomes negative 2 multiplied by 2 minus 2 lambda plus 1 multiplied by negative 4 plus lambda plus 3 multiplied by 3 lambda is 0. So it becomes negative 4 plus 4 lambda minus 4 plus lambda plus 9 lambda is 0. 5 plus 9, 14 lambda is 8. So lambda is 8 over 14 or 4 over 7. Hence, R vector becomes 2 minus 2 times 4 over 7, negative 4 plus 4 over 7, and 3 multiplied by 4 over 7. And let's make a common denominator. It's 14 minus 8, it's 6, and negative 24 over 7, 12 over 7, and magnitude of this vector is the required shortest distance, the minimum distance. And magnitude is what is square root of the sum of squares, and 1 over 7 it's a common factor. Square root of 6 squared plus 24 squared plus 12 squared. Six squared plus 24 squared plus 12 squared, and then divided by 7. Yes, it's correct. It's 3.9. 3 to 3 significant figures. The second method is to consider just arbitrary chosen point, and position vector is r, and distance from the origin to any point on the line becomes just magnitude of this vector. So it's a square root of this actually, and again magnitude or length of a vector, it's sum of squares of its components, so it becomes 2 minus 2 lambda squared plus lambda minus 4 squared and plus 3 lambda squared. And if we need the minimum distance, it's the shortest distance, so this function should be minimum, and minimum or maximum it's when its derivative is equal to 0, and square root of something is minimum when this expression under square root is minimum. So derivative of this should be 0. And you may expand, or it's chain rule, and something squared, it's 2 times this, and this derivative, which is negative 2, and plus 2 times lambda minus 4, and this derivative it's 1, and plus 9 lambda squared, so it's 2 times 9 lambda is 0. Can divide by 2 to get negative 4 plus 4 lambda plus lambda minus 4 plus 9 lambda is 0, and you can see that we get the same value for lambda, which is 8 over 14 or 4 over 7, and 4 over 7, yes, and you can see that it's absolutely the same expression for the magnitude, and if you substitute 4 over 7 for lambda, you will get absolutely the same magnitude of this vector, and it's the required shortest distance. And the third method if we consider origin and vector b, and you can move a vector parallelly, its components remain the same, and we can draw vector b somewhere here, and if we consider some specific point with specific coordinates, and we can consider this point 2, negative 4, 0, 2, negative 4, 0. It's a point on the line, and this vector OA, it's a vector from the origin to some point on the line. Then the shortest distance is this distance, and this distance is perpendicular projection of this vector OA onto vector B. It's this vector. It's called perpendicular projection, and magnitude of this vector of this perpendicular projection is the required shortest distance. And how to find this perpendicular projection? It's cross product of this vector OA and this vector B and magnitude, and divided by magnitude of B. And what is why it's true is because what is cross product? It's magnitude of AO multiplied by magnitude of B and multiplied by sine of the angle between them and divided by B magnitude. You can see it cancels, and we get that it's AO magnitude and times sine of alpha. Alpha is here, and you can see that magnitude of AO multiplied by sine is this distance, and you can see that it's a required distance. In general, it may be considered AO, it doesn't matter, and in general it may be distance from some point, not from the origin. So for example, if it's from point B, the shortest distance to the line, so you can see the BA or AB and then perpendicular projection. So let's check AO. It's 2 negative for 0 is because origin is 0 0 0 and coordinates of a point are the same because position vector starts from the origin 0 0 0, so coordinates of a point are the same. And vector B it's negative 2 1 3. And to find cross or vector product, you may use formula which is given in a data booklet. I use another formula, and when you multiply two vectors, you get a vector. Dot product, the answer is a scalar, just a number. Vector product, the answer is a vector. And I use the next method. It's a determinant of the next matrix. It's I, J, K, and AO negative 2, negative 4 0 and negative 2 1 3, and it becomes plus A, always plus plus I, then remove this row and this column and multiplied by determinant of this 2 by 2 matrix, which is this product minus this product, so it's negative 12 minus 0, so it's just negative 12. Minus J, always minus J, and remove this and determinant of this 2 by 2 matrix, which is this product minus this product, so it's 6 minus 0, just 6, plus K, and determinant of this 2 by 2 matrix, it's 2 times 1 minus negative 2 times negative 4, so it's 2 minus 8, it's negative 6. And then we need magnitude of this vector, which is cross product of AO and B. It's square root of and 12 squared plus 6 squared plus 6 squared, and divided by magnitude of B. It's 4 plus 1 plus 9, and it's root of 14 So it becomes the square root of 12 squared plus 36 plus 36 and divided by square root of 14, and we can see that we get the same result. The next, a plane P is defined by, question C, verifies that P contains L. If we consider just a point, a single point, how to show that it lies in the plane, you just substitute coordinates of a point, and if it's true, it implies that the point lies in the plane. If we consider a line, we substitute for x, for y, for z in terms of parameter, and it must be true for all values of parameter, and it means that for any lambda, it means any point on the line lies in the plane. So let's substitute for x. It's 2 minus 2 lambda minus 3 negative 4 plus lambda plus 5 times 3 lambda is, it's the left hand side, it's 12 minus 12 lambda plus 12 minus 3 lambda plus 15 lambda, and you can see that it's just 24. So 24 is equal to 24 for any lambda. Hence P contains L. Or maybe not necessary to write for any lambda, just it means that left hand side or left hand side is equal to right hand side for any lambda. The next, a second line M is parallel to P. The line M passes through the point and intersects the z-axis. Question D, find the equation of M, expressing your answer in the form. So it's what? It's position vector of any point on the line M, and since we know the coordinates of a point, position vector, it's from the origin, and components of a vector, it's coordinates of the endpoint minus the coordinates of the starting point, and it's just directly this 4, 1, 2. And we need direction vector. It's any vector of any length which is parallel to our line. And if line M intersects or passes or intersects the z-axis, it means that point 0, 0 and some z coordinate, which is not 0, or in general maybe 0, so a point 0, 0 z belongs to our line, or lies on our line. And we know that, so there are 2 points, this 4, 1, 2 and 0, 0 z, and if we consider this vector from point 0, 0 z to 4, 1, 2, and this vector is parallel to our line and can be taken as direction vector. So we can say that D is for 1, 2, minus 0, minus 0, minus z, or just for 1, 2, minus z. And that should be found to get vector D. And also we know that our line is parallel to the plane. If line is parallel to the plane, if we consider normal to the plane, you can see that normal and the vector D are perpendicular, so normal and dot product D is equal to 0. How to find normal to the plane? Normal components of a vector which is normal are just these coefficients, 6, negative 3, 5. It's directly from vector equation of the plane. You can see, if you use this, you can see it's x, y, z, and if you consider this dot product, you get that x component of normal multiplied by x, y component of normal multiplied by y, and z component of n multiplied by z, and hence coefficients in front of x, y, z give us normal. So it's what? 6, negative 3, 5. So dot product becomes 6 times 4 plus negative 3 times 1 plus 5 multiplied by 2 minus z, and it's 0. So it becomes 24 minus 3 plus 10 minus 5z is 0. So it's what? It's 31 over 5 is z. Hence D vector becomes 4, 1 and 2 minus 31 over 5. It's what? It's 10 over 5, so it's negative 21 over 5. It's correct, and we can write directly this, but usually we take direction vector to be in smallest integers, and it would be better not. Oh, it doesn't matter actually. So you may write like this, or you may write finally that it's 4, 1, 2 plus mu 4, 1, negative 21 over 5, or multiplying by 5 to get 25 and negative 21. It doesn't matter, it's correct. This or this. And that's all for this question.